Hello, geometry students. Today we're going to be going over the Unit 2 review. That's at the end of the Unit 2 packet. If you can, what I would like for you to do before this video is simply pause the video now and try to answer as many questions as you can on your own. I'm going to be going over all the material, but it's all material that we've gone over before. So see if you can do some of them on as many as you can on your own, and then just refer to the spot on the video where I go over the topics that you don't know. I also want to emphasize that everything I write, you should be writing in your packet as part of your answer. And so with that being said, we're going to go ahead and get started. And let me share my screen here. Here we go. Okay. Okay. So on the review, and if you can go to the review, it starts on page 30. It has these three definitions to start, right? Define parallel lines, define skew lines, define parallel planes. So those you can find in your packet. Those are towards the beginning of the packet. And I actually wrote out a key for all the definitions here. So for questions in the review, questions 1, 2, and 3, you can find those three definitions on page 3 of the workbook. Okay. And so for questions 1, 2, and 3, that's these: define parallel lines, define skew lines, define parallel planes. You can find those definitions on page 3 of the workbook. So I want you to go to page 3, find those definitions, and put them in there in your packet. Okay. And these are the rest of the definition problems in the review. So like question 5, 6, 7, 8, these are all definitions, right? Define alternate interior angles, same side interior, so on. Those can be found 5, 6, 7, and 8. 5 and 6, you can find those definitions on page 4. And 7 and 8, you can find those definitions on page 5. Okay. And so I want you to just, for all the definition problems, just go back through the workbook, go to these specific pages, and answer these specific problems in the review. Okay, so this is the question in the review, and this is the page you can find it, find that answer, find that definition in your workbook. Okay, so you can go through, maybe pause the video right here where you have this key basically, and go back through and answer all those definitions, write them in. Okay, I want to emphasize that everything we go over in the review will be on the test. All right, so every one of these definitions you need to know if you want to be able to get them right on the test. All right, so with that being said, I'm not going to go over what these definitions should be. You can find those in your packet and write it. I expect you to be able to answer those from going through your packet. Okay. All right, let's go on to page 4 then. So in the following diagram, name a pair of parallel planes. Name a pair of parallel lines, skewed lines, and parallel planes. Okay, so for parallel lines, you can basically pick any two lines as long as they're on the same plane and kind of just going the same way, right? So, for example, AE and DH are parallel lines. So we would write AE and DH is an example. Okay, now you don't have to use that example. There's plenty of parallel line segments in this picture, but AE and DH are parallel lines. Are parallel lines. Okay. All right. All right. Well, what about skew lines? So Skew lines, again, are lines that do not touch, but they're also not on the same plane. So they're on different planes. So like if I say AB, I'm looking for a line that does not touch this and also does not go the exact same way. So I can maybe say CG. These two don't touch each other, and they're not going the same way. They're not parallel, right? They're skewed. So we'd write AB and CG. Now, that's not the only pair you could use. There's plenty of other pairs. So if you used a different pair, as long as they're skew, right, they're on different planes and not touching, then you can say they're skew lines. So I want you to write AB and CG, and I want you to finish the sentence. Are skewed lines, or are skew lines. Okay. Now, parallel planes. Parallel planes, I think, is pretty easy. Is just two planes that don't touch each other. So either this top of the box and the bottom, those would be parallel planes, right? Those planes don't touch. Or the left plane and the right plane. All right, so let's just go and use the left and right planes, okay? So left and right planes. So how would I name this plane on the left? A, B, F, E. So plane A, B, F, E. So that's the left one. And plane DCGH. DCGH. So those are example of parallel planes. Now, if you use the top and bottom, that's fine. Or if you use the front and the back faces, that's fine too. And I want you to finish that sentence, are parallel planes. Okay, so plane ABFE and plane DCGH are parallel planes. Okay, these definitions for 5, 6, 7, and 8. Again, you can find those 5 and 6. You can find those answers on page 4. 7 and 8, you can find those answers on page 5. Okay. Number 9. Label the areas that are exterior and interior. So we talked about this before. Interior is inside. Interior is inside. So 3, 4, 5, and 6 are what we'd call interior angles. Okay, so these are interior. And 1 and 2 are exterior. Exterior. And then 7 and 8 are also exterior. Okay. Interior, inside. Okay. Exterior, outside, right? Like the exit takes you outside. Okay. In the image below, answer the questions 10 through 13. All right, so we have this picture. We have lines L and M here, and they're cut by transversal T. So label all pairs of alternate interior angles. Okay, so we're looking for alternate interior angles. So since it says interior, we're looking at the interior angles. So that's C, D, E, and F. Those are the interior. So alternate interior would be like angle C, and what would be its alternate interior counterpart? Angle C with angle, well, that'd be F. See how it's on alternate sides of the transversal? And they're interior, right? So angle C and angle F. So that's one pair of alternate interior angles. So that's one pair of alternate interior angles, C and F. Okay. There should be two pairs in total. So we have one pair I gave you right here. See if you can come up with the second pair of alternate interior angles. So I gave you one pair. See if you can find the other pair of alternate interior angles in this picture. Next, list all pairs of same side interior angles. So same side interior. So interior, again, we're looking at C, D, E, and F. Those are the interior angles. So which ones would be considered same side? So angle C, what would be its same side interior counterpart? Well, it's on the same side. So C on the same side is E, right? So C and E, those two angles are same side interior angles. All right. I gave you one pair. See if you could find the second pair of same side interior angles. Next, question 12. List all pairs of corresponding angles. So corresponding angles, a little bit different. There's going to be 4 pairs of corresponding angles. 4 pairs. So there should be 4 pairs in total for question 12. Let's go over one pair. So angle C, what would be its corresponding? Well, the way I think of corresponding is like when I look at these 4 angles here, A, B, C, and D, they have each of them have a corresponding one over here. So notice C is in the bottom left of these 4. So G is in the bottom left of these 4. And so they're in corresponding position. They're in corresponding position. So angle C is a corresponding angle to angle G. So angle C and angle G are a pair of corresponding angles. All right. What would be another pair of corresponding angles? So I said C with G. Well, maybe what is A's corresponding angle? So notice A is in the top left of these 4. So which one's in the top left of these 4? Well, that'd be E. So angle A and E, they're in corresponding position. Angle A and angle E. Okay, so I gave you 2 pairs of corresponding angles. There's 2 more pairs of corresponding angles. 2 more pairs of corresponding angles in this picture. See if you can find the other 2 pairs of corresponding angles. So there should be 4 pairs in total. All right. List all the pairs of alternate exterior angles. So exterior, we're looking for the outside angles, and we're looking for alternate exterior. Now, if you recall, so each exterior has an alternate, right? So for angle A, it's an exterior. What would be its alternate exterior pair? Well, it's on the alternate side of the transversal. It's over here, actually. So angle A with angle H in this case. Angle A and angle H. So that would be one pair of alternate exterior angles. See if you can find the second pair of alternate exterior angles in this picture. So I gave you one pair. See if you could find the other one on your own. Okay, moving along. Question 14 and 15, these are just definitions, and you can find those in the packet. For questions 14 and 15, you can find both of those on page 9 of the workbook. All right, so go ahead and go to page 9 of the workbook, find those definitions, and write them in. Okay. Question 16. In the image below, identify all the angles that are congruent to angle 4. So here's angle 4, and I want to find all the angles that are congruent to that. All right, and give the reason you know. Now it tells us that L is parallel to M. So we have 2 parallel lines cut by a transversal, and we want to find all the angles that are congruent to angle 4. So angle 4 is congruent to what? Well, notice that this angle, how much it's open, right? So it's an acute angle, meaning less than 90. And you can see what other angles are open that same amount. Well, you could see angle 8. You can see that this angle is open the same amount as angle 8. I hope you can see that there. As well as angle 6 and angle 2. So in this case, all the angles that are congruent to angle 4 will be angle 2, angle 6, and angle 8. And we're going to talk about the relationship for each of those. So for angle 8, let's take a look. So 4 and 8, what is their relationship? So hopefully you can see that these are corresponding angles, right? Angle 4 is in the same position as angle 8, right? Bottom left of these 4. So angle 4 is congruent to angle 8, comma, because they are corresponding angles. They are corresponding angles. running out of space there. Okay. Now we're going to do the same with same idea for angle 6 and angle 2. So angle 4 is congruent to angle 6. And what's their relationship? So what's the relationship between angle 4 and angle 6? They're not corresponding in this case. What would be their relationship? Because they are, in this case, alternate interior angles. All right, so I want you to write that. So angle 4 is congruent to angle 6 because they are alternate interior angles. Alternate interior angles. So finish that sentence there. And then lastly, angle 4 is congruent to angle 2. Because why? Well, what's the relationship between angle 4 and angle 2? In this case, because they are vertical angles. Vertical angles. So you can see they share that vertex, right? They share that vertex, so that makes them vertical angles. Okay, so when they share a vertex and they're on opposite sides like that, we call those vertical angles, and vertical angles are always congruent. Okay, so 4 is congruent to 2 because they are vertical angles. Go ahead and finish that sentence there. All these should be complete sentences. All right, number 17. This one's a little more complicated. We haven't done anything like this in the packet necessarily. We did a little bit, but nothing where we had to start from scratch, where they don't give us any information here. So we're going to go ahead and work on this. So let's see. They want us to prove that angle 2 is congruent to angle 7. So prove that angle 2 and angle 7 are supplementary. All right, let's talk about that for a moment. So what does supplementary mean? So from our definitions, hopefully you look that up and remember it, but supplementary means that the two angles add up to 180 degrees. So we want to prove or show how we know that angle 2 and angle 7 will add up to 180 degrees. So how do we know that? That's what we're trying to show. We're using a 2-column proof. That's just this format, basically. A 2-column proof, you put the statement over here, and we put the reason why we know that statement on the right. All right, now it says line L is parallel to line M, so we have two parallel lines cut by a transversal T. And let's go over this. So usually with these 2-column proofs, we want to start with whatever we're given. So whatever information they give us, we want to start with that. So they say that line L and line M are parallel. So let's go ahead and write that. Line L is parallel to line M. So I'm writing a shorthand here, but you can just copy like how I did. So when you see two lines like that, that means these two are parallel. So this, you'd read this as line L is parallel to line M. And the reason we know that's true, how do we know that these are parallel? Well, they told us already, right? They just told us that. Line L is parallel to M. So if they just tell us, we say given. Okay. So anytime they just give us that information, we say that we know this information because they gave us that, right? It's given. All right. Now let's take a look. We want to somehow come up with a relationship between 2 and 7 here, right? So we want to relate angle 2 to angle 7. Okay. So here's angle 2 and here's angle 7. What I would start with is I could relate angle 7 to angle 1 because I know angle 7 and 1, they are congruent to each other, right? So I could say that angle 7 is congruent to angle 1. In other words, angle 7 and angle 1 have the same measure, right? So 7 and 1, they have the same measure. And how do I know that? Well, they're alternate exterior angles, all right? And alternate exterior angles are always congruent when you have parallel lines. So when you have parallel lines, alternate exterior angles are congruent. So 1 and 7, angle 1 and angle 7 are congruent. All right, so we know this because they are alternate exterior angles. Okay. Okay, so now I know that 1 and 7 are congruent. And now I can say, well, what do we know about the relationship between angle 1 and angle 2? Well, angle 1 and angle 2 are supplementary. So angle 1 and angle 2 are supplementary because they share that same line together. Do you see how these two share this straight line together? And if you recall, when two angles create a straight line together, we call those a linear pair, and a linear pair are always supplementary. So we know angle 1 and angle 2 are supplementary because they are a linear pair. So we write linear pair. Okay, so we know that angle 1 and angle 2 are supplementary because they are a linear pair. So if 2 is supplementary to 1 and 1 has the same measure as 7, then 2 must be supplementary to 7. So angle 2 and angle 7 are supplementary. And that's because, really, it's because 1 is congruent to 7 and 1 and 2 are supplementary. So that means 7 and 2 are supplementary because 7 and 1 have the same measurement, right? So if this is true, then I could just replace this angle 1 with an angle 7 and they would be supplementary as well. So this is really because of substitution. So whenever you replace one thing with another thing when they're equal, we call that substitution. All right? All right. I know that one was kind of tough. The one on the test will not be this hard. You'll just have to come up with one of these reasons, I think, in the question. Question 18. What are the measures of angle 5 and angle 3? Which theorem or postulate justifies each answer? So here's angle 5 and here's angle 3. And they only give us that this angle right here is 75 degrees. So we know that this is 75 degrees. And we also know that L and M are parallel to each other, right? We know that because they give us these little arrows. And generally when they put those little arrows on the lines, that means that those two lines are parallel to each other. So they're telling us L and M are parallel. And we want to find the measure of angle 3. So when we're writing the measure of an angle, usually we write M angle. So this would be the measure of angle 3 is. So what's the relationship between the 75 degrees and angle 3 here? Like, what's their relationship? Are they corresponding? Are they same side interior? What are they? Hopefully you can see that these would be alternate interior angles. Alternate interior. So the measure of angle 3 is also 75 degrees because they are same side interior angles. Because alternate interior angles. Alternate interior angles. Alternate interior angles. Okay. Now, what about the measure of angle 5? So how does that relate to this 75 degrees? Are they alternate interior, alternate exterior? Are they corresponding? Are they same side interior? Well, hopefully you can see that they are corresponding position, right? So this one's in like the top left of these, and the 5 is in the top left of these. So they're in corresponding position. So the measure of angle 5 is also 75 degrees because of corresponding angles. So again, complete this sentence. I want you to finish writing this out because of corresponding angles, because they are corresponding angles. Okay. Okay. Question 19. Identify which lines are parallel if angle 4 is congruent to angle 6. Justify your answer. So first, let's find those two angles that they're talking about, angle 4 and angle 6. And they're saying that those two angles are congruent. So angle 4 is congruent to angle 6. Okay. Now, the way I like to do these is I look at, okay, which lines are involved with these angles. So you can see with angle 4, which lines are involved? Well, line A is involved and line L is involved, right, with angle 4. You see that? With angle 6, L is involved with angle 6 and also B. So when I'm looking at angle 4 and angle 6, the lines that are involved in creating those angles is L, A, and B. See, M is not involved with these angles. So when I look at those angles that are involved with angle 4 and angle 6, L, A, and B, which of these angles would be parallel to each other? Well, hopefully you could see that A and B would be the parallel lines in this case. So that means, A is parallel to B, comma, because. So whenever they say justify your answer or give a reason or something like that, you're always going to say, this is the thing, because, and then give that reason. So whenever we're showing lines are parallel, in this case, whenever we're showing lines are parallel, hopefully you remember we would use one of the converse. So because converse, so that's a key word. Whenever we're showing lines are parallel, you're going to be using one of these converse properties. So it would be converse of, and then what's the relationship between angle 4 and angle 6? What's the relationship? Are they same side interior? Are they alternate interior? Are they corresponding angles? Hopefully you could see that they are in corresponding position, so they're corresponding angles. So converse of corresponding angles. Okay, please write in complete sentences, and let's move on. So question 20, it says, given that the measure of angle 4 plus the measure of angle 5 equals 180 degrees. All right, let's stop right there. So what does that mean when two angles add up to 180 degrees? What do we call that? They're supplementary, right? So in other words, they're saying angle 4 and angle 5 are supplementary angles. All right. Now, in the image below, write a flow proof to prove that L, line L, is parallel to line M. All right. We're not going to do a flow proof. We're just gonna write basically sort of like how we did up here. All right. So here I'd write L is parallel to M, comma, because why? So we would look at our two angles that they're talking about. So in this case, 4 and 5. So angle 4 and angle 5. And they say that there's a supplementary to each other. So what's the relationship here between angle 4 and angle 5? Hopefully you can see that they are same side interior. Okay, same side interior. Now remember, I discussed this in the last problem. Whenever you're showing lines are parallel, you're going to be using converse of something. So L is parallel to M because of converse. In this case, in this one's case, it's same side interior angles. Same side interior angles. Interior angles. Okay. All right, let's move on. Question 21. There's a bit of a typo here. You could see it in the problem. It says in the picture below, if angle, and you can't really see what it says there, but it should say angle 1 is congruent to angle 2. That's what it should say. Are lines R and S parallel? Explain your reasoning. So again, we want to show that lines are parallel, right? Because it says, are these two lines parallel, R and S? So we're going to be using one of those converse properties, right? Because whenever we show lines are parallel, we're going to be using converse of something. Now, in this one's case, we know that angle 1 and angle 2 are congruent. So here's angle 1 in the picture, and here's angle 2 in the picture. Okay, so these two angles are congruent. So we could say lines R and S are parallel. Because why? Okay, so because. And remember, we're showing lines are parallel, so we're going to be using converse of what? In this case, what's their relationship? These are alternate interior angles. So alternate interior angles. Alternate interior angles. Okay. Here I should have put of here, so this should be converse of. Yeah. Okay. Converse of alternate interior angles in this case. Okay. So again, anytime you're showing lines are parallel, you're going to be using converse of, and then you basically look at what's the relationship between the angles that we're working with. In this case, 1 and 2, and these angles are alternate interior. Okay. Question 22. What must the value of x be if L is parallel to M? Explain your reasoning. Okay. Here, let's not worry about explaining our reasoning too much, but what I do want to point out is the explanation. I do want to point out the explanation here. So in this one's case, notice the relationship between the angles we're working with. So what's their relationship? Are they going to be congruent to each other, right? Or are they supplementary to each other? So are they congruent or supplementary? In this one's case, you can see this one's acute, right? This one's acute angle, but this one's obtuse angle, right? You can see they don't even look like the same measure, right? They're not the same measure. They're not congruent. In fact, they are supplementary. And hopefully you can see that because they are same side interior, right? They're on the same side of the transversal and they're interior. So same side interiors, those are supplementary. So what does that tell us? That tells us that these two measures should add up to 180. And they will add up to 180. So the 4x plus 20 plus the 60 degrees, these two measures together will add up to 180 degrees. And from here, it's just a little bit of algebra. We want to solve for x here because it says, what is the value of x? That's what we're trying to find, the value of x. So in this one's case, we can combine the 20 and 60. So this will become 4x. And again, whatever I write, you should write, write out all your work. Combining the 20 and 60, that makes 80. Nothing happened on the right side, so that's still 180. Now, how would I get x by itself? What should I do first? Well, hopefully you can see that you would subtract 80 both sides of the equation. So subtract 80 on the left and on the right. This will give you that 4x equals 100. Well, what would be the next step in getting x by itself? Well, we need to get rid of this 4. So how do we do that? Well, I would divide both sides by 4. So you divide by 4 here. Divide by 4, divide by 4. And that'll give you that x equals 100 divided by 4. That's 25. Okay. There's your answer there. Okay. Hope that made sense. I know it's a little bit of algebra, but it's not too terribly bad. Questions 23 and 24, these are definitions again. Hopefully you know those definitions, but if not, you can find those on page, so for problem 23 and 24, you could find those on page 19 of your workbook. You find those definitions. So go ahead and turn to page 19 of your workbook and fill in those definitions there for questions 23 and 24. Okay. Now, just a few more problems left. Okay, almost done. Here we want to find, for question 25, we want to find the value of x and the value of y. So in this picture, if you recall, in any triangle, the three angles in a triangle always add up to 180. Okay, so when you see three angles three interior angles of a triangle, the three angles always add to 180. Okay, so that means that in this triangle, this left-hand triangle, well, we have two of the angles, 60 degrees and 40 degrees, and we should be able to find the measure of x because together these three angles should add up to 180. So 60 plus 40, well, that's 100. So what does x have to be? Well, x would have to be 80. Okay, so that these three angles together add up to 180. So now we know from that x is 80 degrees. Now, what's the value of y in this case? Well, if you recall, you could see that these two angles here form a straight line. They form a straight line together. Now, what does that tell us? Well, remember when two angles form a straight line, we call those a linear pair. A linear pair. And a linear pair, they always add up to 180 degrees because a straight line, any straight line, is 180 degrees. Therefore, if I split this into two angles, these two angles will add up to 180. So same idea here. So if this one's 80, that means y must be 100 so that they correctly form a linear pair. Okay. We could also find angle z. They're not asking about that, but we might as well find it as well. If we look at this right-hand triangle, you can see that this angle up here is 50. This one is 100. So we can find this third angle because the three angles together always add up to 180. So that means z must be 30. Okay. They didn't ask about that, but you could still find it. Okay. Now we're going to use those ideas that we just talked about to help us with questions 26 and 27. So in question 26, they give us that this angle right here is 75 and this angle is 28. So we should be able to find this third angle right here inside. So we can find this interior angle right here. Well, how would I find that? Well, remember the three angles inside, this is not angle 1 yet, angle 1's outside, but the three angles inside should add to 180, right? They always add to 180. So let's go ahead and add 75 plus 28. Okay, that gives me 103. So what do I need more to get to 180? So 180 minus that gives me 77 degrees. Okay, you could always check to make sure that these three angles in here should add to 180. Now we can use the fact that this 77 degrees and angle 1, they form a linear pair, right? They form a linear pair. So that means that this angle 1 must be 103 because they add to 180 together. Okay. You may already notice this, but notice the 75 plus 28 add up to 103. So that's a pattern that you can use to find that quickly. But if you forget that pattern, always just find the stuff that you know. The main thing I want you to know is that a linear pair always add up to 180, and also that the three angles in a triangle also always add up to 180. So in our case, the measure of angle 1 equals 103 degrees. Okay. Number 27, we want to find the measure of angle 2. So here it's kind of like the last problem. We're just kind of doing it backwards. So here they give you this as 121 degrees. So we can use that information to help us find this angle on the inside, the angle next to it, because these two angles are a linear pair, right? So I could just do 180 minus 121, and that'll give me that this angle right here is 59. And again, I know that because these two must be supplementary. They must add up to 180. Okay, so now I can use that information to find angle 2. The three angles inside the triangle always should add up to 180. So if I know two of the angles, I can always find the third one. In this case, 64 degrees. And you could always double check because the three angles in here should add to 180. Okay, so the measure of angle 2 in our case equals 64 degrees. All right. Number 28. What is the value of angle S in the diagram below? So they don't tell you this, but this is supposed to be a parallelogram. It is a parallelogram. That's important. Number 28 should say, given that PQRS is a parallelogram, but that's okay. In a parallelogram, the opposite angles are congruent. So angle P and angle R are the same measure, opposite angles. And Q and S are the same measure as each other. But what about angle S and P? Well, they're not the same measure. You could hopefully already see that. Angle P is far more closed than angle S, right? Angle S is more open. So it has a higher measure for sure. Well, these two angles together, although they're not congruent, they're actually supplementary. They're actually supplementary to each other. So that means we can find it. 62 subtracted from 180 gives me 118 degrees. So the measure of angle S in our case equals 118 degrees. Okay. Okay. Using a system of linear equations, solve for x and y. So here we have a parallelogram again. And what we want to recall is that when the diagonals of a parallelogram cross each other, they bisect each other, meaning that the length from L to the center, I'm just going to go and call the center Q. Okay. So L to Q will be the same length as N to Q. Similarly, K to Q will be the same length as M to Q. So therefore, since L to Q is the same as N to Q, then I could say LQ, well that's 2x, equals NQ, which is 4. Solving for x here, we would divide by 2 and divide by 2 to get x by itself. Therefore, x equals, and 4 divided by 2 is 2. So that gives us the value of x. And we still need to find the value of y here. So what's going to be the system of equations to help us find y? Well, we have to use the fact that MQ is congruent to KQ. So MQ, which is 2y minus 7, will be congruent to y minus 1. So these will be equal here. So my goal is to get y by itself here. So what I would do first is notice that there's y's on both sides of the equation. We don't really like that. So we're going to subtract y on the left and subtract y on the right. So that way there won't be any y's on the right side. There will only be y's on the left side. And so 2y minus y, that gives you 1y, or just y, it's fine. So here we'll have 2y minus y, that's y. And then we solve a minus 7. And on the right side, we have a negative 1. So how would I get y by itself here? Hopefully you would see that you could add 7 to both sides of the equation to get y by itself. That's y equals negative 1 plus 7 is 6. So now we know our x and we know the y. All right. Now this one, we have a bunch of parallel lines. It says in the figure below, AE is parallel to BF, is parallel to CG, is parallel to DH. So in other words, we could see there's 4 parallel lines. So these 4 lines are all parallel to one another. AE, BF, CG, and DH, all parallel to each other. Okay, then it says AB equals BC equals CD equals 2. So AB, so that's the length from A to B, this length here. And it says that length is 2, right? Because it says it equals 2. BC also equals 2, so the length from B to C. And then CD, the length from C to D, is also 2. So the total length here you could see is 2 plus 2 plus 2. Now, let's figure out what other information they give us. So, and it says, and EF is 3.2. So the distance from E to F is 3.2. That's from E to F. Okay. So since these lengths on the top are all the same, these distances on top are all the same, that will make these distances on the bottom the same as well. So EF was 3.2. So that means FG must also be 3.2. And GH must also be 3.2. All right. Then it says, what is EH? So we want to find the length from E to H. E to H. So that's going from here, from E, all the way to H. So what would be that total distance going from E, walking all the way to H? Well, hopefully you can see that you just add 3 plus 2, plus another 3 plus 2, plus another 3 plus 2. Or 3.2, I should say. 3.2 plus 3.2 plus 3.2. 3.2 times 3. 9.6. So the length of EH is 9.6. And that's the last question. So if you did everything and you followed everything, you should get 100% on that, provided that, of course, you were able to. Let me stop presenting here. There we go. Stop presenting. Okay. So hopefully you're able to get that all done. And if you have any, if you're having any trouble, you could always ask for help. Okay. Well, with that, good luck on the test. If you know the review, if everything on the review made sense, then the test should be easy, because everything in the test was covered in the review. So if the review made sense, then the test will make sense. And it should be relatively easy. All right. Well, with that, take care, and I'll see you guys next time.